Hello everyone. So today I will be doing the second part in the Arduino Starter Kit. It's titled Spaceship Interface, and it looks like we're just going to be setting up a bunch of LEDs on our board, and then instead of just sending power through, we're going to do some programming with the Arduino editor and to make it behave in a certain way when you press a button. So, with that in mind, let's get started. So here's the circuit diagram. Just three LEDs in series, each in series with a resistor, and then a push button controlling the voltage through. So yeah, let's do that. Yeah. So it looks like we're going to need three 220 ohm resistors, and we are going to need a 10k resistor. Okay, so you remember from last time, talked about the resistor bands. So this resistor is a red, black, black. So that's 220 times 10 to the 0, which is 1. So it's just a 220 resistor. So we need 3 of these, so 3 of the blue ones with the red, black, blacks. So I have 2 right here. I just need to find one more. They give us this nice collection of resistors here. Let me just pull out the one. And then we need a 10k ohm resistor. So right here I have a brown, black, red. So brown is 1, black is 0, so that's 1, 0. Red is 2, so times 10 to the 2. That's 10 times 100, 1000. That's a 1k ohm resistor. So let's see. That is not what we're looking for. We're looking for a 10k ohm resistor. So we're gonna want a brown, black, yellow. Yellow is 3, so 10 times 10 to the 3, which is 10,000. Let's just look for one of those. Yeah, it's actually orange, not yellow. Bad. Yeah, but the orange refers to 3, so 10 to the 3. So now that we have our resistors, we can start putting it together. So let's just put our things back into our kit when we're not using it, so we can stay organized. Drop to resistor. They're very small, easy to lose track of. Let's get right into it. We only need one button, so I'll take away this other button. And we need 2 more LEDs, so I'll grab a green and a red LED. Okay. Yeah. Let's do this. So we need to connect our 3 LEDs like we did last time. So we'll do so, except this time instead of connecting it directly to power, what we're going to do is we're going to connect it to one of the digital pins on the side here so that we can program the LEDs to behave in a certain way. So let me grab my longer wires, guys. I'm gonna need 3 of them. So we can do pins 2, 3, 4, and 5 for our project. So here, 4. Yeah, there for now. I'm gonna put our LED in now. As before, the longer end, the anode side, will be connected to the power. Okay. Then we connect the anode to the power controlling pin, which is this yellow wire. Cool. Now we get our resistor in series, and then we connect that to ground. So to the cathode side, negative end, and just like that. Cool. I'm just freaking out a little bit. Okay. Next, we do the same thing for the other 3, for the other 2. I'm gonna change this to pin 5. I'm gonna go in order from top down, 5, 4, 3, 2. 1. So it's good to keep in mind which pin, because when we're gonna do the coding, we are going to need to keep track of what pins we use so we can get it to function properly. So, use our red LED. Get this to focus again. Okay. Like so. Then we will connect it to ground. Resistor. So. And once more for our green LED. This. Cool. This. Little finicky. Cool. So now that we have that set up, the next is our switch mechanism. So, grab our push button, and we will connect it like how we connected it in the first project. Okay, and then first we need to connect this to power, so plus goes to button. So up over there. Okay, and then we need we take our 10K resistor and we are going to put it to ground. Connect it to ground. So okay, and lastly, we need to connect one of the ends of the push button, the negative end, to our Arduino one of the digital pins so it can be coded to do what we want it to do. So we connect it to the 2-pin. So now the hardware aspect of this is complete. Cool. So we basically have these yellow wires and green wires. They're telling the board is going to supply the power in a certain way that we will code so that the LEDs behave or light up in a certain fashion. Once again, the resistors are used to complete the circuit and to make sure that they don't get shorted out. And same with the button. It also has that resistor, and it's connected to the power normally, and then the negative end is connected with this green wire, which will tell us, so then we can edit the behavior in the code. So with all of that in mind, let's go into the coding aspect of it. Okay, now that we have a good setup for our coding, let's jump right into it. So the book actually gives you the code, and then they do a very good job explaining of what each line is supposed to do. So the Arduino code is similar to C in a sense where the syntax is very close to each other, but it's a little different. So first we need to declare our variables for things like the switch state, as in if the switch is on or off. So int, it's just going to be an integer, switch state equals 0. So we are just declaring it to be 0 for now, so then we can change it when we need to. So now we go into our setup code, which is, as highlighted here, it's run only once, and then it basically just initializes everything. So then we can, it only runs once, and it's just starting everything up. Let's do that. So first, with the Arduino, as we mentioned with the pins earlier, it's important to notice, or to keep track of which pin is connected to which LED, because we need to declare our pin associations by using this pin mode function. So what you do is you specify which pin you're talking about. So in this case, we're talking about pin 3, which is on the board connected to one of the LEDs, and then we're saying it's an output. An output as in we want it to do some sort of behavior. And then in the other case, it would be an input pin, which means that we are going to take some sort of information from the circuit element that will help us do something. So in this case, all the LEDs are outputs because we want it to do something, and then the button is a input because we want it to tell us, we want it to push and then do something. So that pushing is bringing some information in the circuit. So we put the button to pin 2, so we declare it as input as so. So that's cool, and that should be it for our setup. So now in the loop, this is what's going to be run over and over and over again. So the setup runs once, and then the loop is always ran. It keeps running. So we want it to do a certain behavior. So since we declared our push button as an input, we need to use a function called digital read, which basically says that when you do something with that, the information is read in, and then so our switch state variable, which is originally 0, we're going to change it to be whatever the button reads, and then digital read 2 because that tells it which pin, so it's reading from pin 2 as we declared as an input. So now we can get into some coding behaviors. So it just gives us an if statement. So that's saying if switch state equals low, as in the button is not pressed. So it reads low or high, high for when it's pressed. So if the button state is pressed, and then we add the curly brackets to indicate that we want it to run in this loop, this if statement. So it looks like we are going to turn one of the LEDs on, and then the others are going to be off. So let's have our blue LED turned on. So if you remember, our blue LED is connected to pin 5. So let's do that. So we do digital write 5. So digital write is kind of like the counterpart to digital read, where instead of we're reading in something, we're writing something to the device. So we want it to read so that the blue LED is on and none of the other ones are on. So we write that it's high, as in it's on. High for 1, low for 0, high for power, low for no, not powered. And then the other ones we just turn off by saying so. And then similar to coding in C, we need to add semicolons to suppress the end of a line. If you're not familiar with that, that's why I keep adding the semicolons. So let's keep going. So I just copied that because we want the main behavior. However, we're going to change the if statement to else, because so the if, it'll run through the if and then see, okay, if it's low, then it'll do this digital write stuff. But if it's anything else, then we'll do some other behavior. So in this case, it appears that we're going to switch the outputs so that one of the LEDs turns on and the others are off. So we'll start with the green LED, which is on pin 3. Oh, thanks for following, Erratic Toby. How's it going? Anyways, so yeah, so let's do so. Like so, and next we will add a delay. Just tells it to pause for 250 milliseconds. And then next, let's finish that up so then when we push the button, it does what we want it to do. So right now it's coded to when the button is pushed, the green LED will turn on for a little bit. And then it looks like we are going to have the red one turn on instead. So we write another digital write. And instead 4 is going to be high, which refers to the red LED. And then 3 is going to be low. So then the green LED turns off instead. And then we are going to delay another quarter second, so that when it loops back to the start, when we push the button again, it'll delay a little bit. So with all of that done, that's it for the code. It should work properly, so let's plug this in. Now I need to upload this. You click this upload button to upload the sketch into the board, and we'll just call it project 2. And it'll compile everything. And because I was typing some stuff. Doesn't like that. Right. Okay, so as we see, the LED is, one of the LEDs is on, messing up the camera. Okay, and then when we push this button, we're going to have it flicker the green on and then the red on, and then it's going to go back to just the blue on. Let's see if that works. Yeah, and it just cycles through. Pretty cool. Yeah, so that's just the basic thing that we did in our code. So what we can do is we can change the code around so that it does different behaviors. So if I switch this to high, infrared detector to make a person counter at an entrance. Let's see. Yeah, I think so. So you could have it so when you detect something going through, a person going through, then it can flicker a count. And then maybe if you want like a visual indication, you could turn one of the LEDs on. And then the computer will keep that running total, and then the LEDs will just flicker on and off when people walk through. You could do something like that, which is cool. Let's see. So let me rearrange this just to show that when we change the code, we can change the behavior. So in this case, it's going to go from red to green and then blue. Right. And then just show some other things. If we change the delay, we can make it go faster or slower. So if I change this to 125, then instead of it going for 250 milliseconds, it'll only do 125. So then it cycles through faster. And then vice versa, we can go the other way around. Make it half a second instead. And then it would take longer for it to switch. Lower. Could also do it so originally all of them are on. Something like this. And then when we push the button, only one of them turns on. Even add some more code here, where this one turns on, the blue LED, and then the other LED turns off. So delay 500, and we delay, load again, and then it cycles through only one of them being on. So you can do various things with the code. Pretty powerful. Yeah, so that's it for the second project. It's mostly just an introduction to how to set up circuit elements to the board itself, and then how to code in some sort of behavior, which is cool. Thank you for watching part 2 of my Arduino Starter Kit series. I'm hoping to do the next part on Tuesday live on my stream, so please follow if you're interested in that. And if you enjoyed watching this video, then make sure to like and subscribe. And yeah, thanks for watching.